Unit 8, Day 1. So today we're going to talk about how to find sides and angles of triangles that are not right triangles. Because if it's not a right triangle, we don't have a hypotenuse and right angle, and we have a lot more things to think about. But let's start with our right triangle that we know and love. So we have this triangle. Your right starts out not being a right triangle, but they want us to find the height, and that's this side here. So what we can do is we can talk about this right triangle because the height is going to be perpendicular to the base. So when we talked about right triangles, we always start with an angle, so 45 degrees. We want to know the height, that's the side opposite the angle we know, and we also know the hypotenuse. So sine sounds like a good idea. That's h over the 7.1. Cross multiply, h times 1 is h, and cross multiply the other way, and I get this. And sine of 45 degrees is root 2 over 2. Half of 7.1 is 3.55. And here is the height of the triangle. To get a decimal approximation for that, that's 3.55 second square root of 2, enter, and we get about 5.020. Notice they wanted to do this two different ways. What if I take this right triangle, and the angle that we know here is 68.2. We're still looking for the height, which is opposite that angle. But now we're given a hypotenuse that's different for this right triangle to the right. So here's the opposite of the 68.2, and there's the hypotenuse. H times 1 is h, and 5.41 times sine is over e. Let's get a decimal approximation for that height, and that's 5.41 sine, since this was not an angle we know. The other one we knew that root 2 over 2 is sine of 45, but this is some sine of some unknown number, 68.2, and do that, and we get about 5.023, and these are close, but they're not exact. My thought is, well, maybe these numbers are giving us our approximations as well. Maybe this 68.2 is an approximation, but I think we have a good handle on this. So we just saw that if we take this right triangle here, that sine of b is h over c. And again, c is the side opposite angle c. We don't label these arbitrarily. The sides are always across the angles are always across the sides. Then for this triangle to the right, we said that sine of c is its opposite, also h, over the hypotenuse for that side. And we solved for h in each case, and we got a different expression, but they're both h because they're both the height of the triangle. If they both equal h, they equal each other. So that's what I did here. And then I uncross multiplied, you might say. Is it c multiplied to sine b? Well, shouldn't that be diagonally across from what might have been a cross multiplication? And isn't b multiplied to sine c? So for the cross multiplication, wouldn't b have been multiplied to sine c? And we have an interesting ratio here, that the side and the angle are related by their sine. In this case, in number 2, the height is outside the triangle. But I can still use this right angle because height is always perpendicular to the side opposite it, or the side extended. So here's the angle of 20.6. The opposite side of the right triangle is h, and the hypotenuse is 8.5. Cross multiply, and we have here height is about 2.99. They want us to find the length of side AB, so that's here. I'm going to call that C if you don't mind. And problem is the shaded triangle is not a right triangle. So little c is not opposite 20.6 in a right triangle. It is opposite, but not in a right triangle. So I can't use sine here, but I can talk about the same little triangle to the left. And so sine of, now, this is 123.7. This is a straight angle, so this angle here is left over from 180, and that's where I get the 56.3. So sine opposite over the hypotenuse, which is the side I want, the AB, cross multiply, and I get to here. Actually, what I did is I switched these two. I put the C here, I put the sine down here. They're still diagonally across from each other. The h is still diagonally across the 1, so this is okay. And then if I pop this into the calculator, I get 3.595, which is what they wanted me to find. So from 1b, they said, let's try this. And so little b, the side opposite angle b, is 8.5. The angle opposite that in the shaded triangle is 123.7. And then side C is over here, the AB I just found a moment ago, and that's opposite this angle in the shaded triangle. Let's try to find C a different way. So I'm going to leave it as C, even though I just found it over here. So I cross multiply this way and this way. To get the C by itself, I divide by this. That's why it ends up down here. And then if I pop this into the calculator and do this division, sure enough, I get the same side C. Looks like this ratio works. So this ratio is going to be called the law of sines, and it's really, really easy. Side, opposite angle, side, opposite angle, side, opposite angle, and the angle is after sine, hence the law of sines. If you flip all the fractions over, you'll get this version. It doesn't matter as long as you're consistent. So either have all the signs on the bottom or all the signs on top. I tend to use this one. It doesn't really matter.